So, today we are going to start our new chapter, that is boat and stream. Before heading to the point, let us first clear some of the basic terminology and basic concepts of boat and stream. Actually, boat and stream is a part of speed, time, and distance. So, first we will deal with the formulas of speed, time, and distance, and the changes in the unit, changes in the length, time, etc. So first, everyone knows that the formula for speed, time, and distance is speed is equals to distance is equals to speed into time, or speed is equals to distance upon time, or time is equals to distance upon speed. We all are familiar with these three formula. Now let us deal with the changes of length. So we will first start with kilometer. Similarly, hectometer, decameter, meter, decimeter, centimeter, last but not the least, millimeter. Ten hectometer is equals to 1 kilometer. Similarly, 10 decameter is equals to 1 hectometer. So as we will move down, we will multiply it with 10. Similarly, 1 kilometer is equals to 1000 meter, because 10 into 10 into 10 into 1000. Okay, 1 meter is equals to 1000 millimeter. And when we move upward, we will divide it with 10 only. So it was all about the unit of length. Now we will move towards the unit of time. So many of us confuse in changing how we change kilometer per hour into meter per second into kilometer per hour into meter per minute into kilometer per hour. So first we will see the basics. If we have to change hour into minute, then we will multiply it with 60. If we have to change minute into hour, then we will divide it with 60, or 1 by 60. If we have to change meter into seconds, then again with 60, and second into minute 1 by 60. We have to change hour into seconds, multiplied by 3600. 60 into 60, 3600. And if we have to change second into hour, then 1 by 3600. So it was a basic about time. Now we will discuss about the conversion of kilometer per hour into meter per second. Kilometer per hour into meter per second. So what we are doing here is we are converting kilometer per hour into meter. It means kilometer into meter, and we have just discussed that 1 kilometer is equals to 1000 meter, then and 1 hour is equals to 3600 seconds. After terminating both the terms, we will get 5 by 18. So if we have to change kilometer per hour into meter per second, then we will multiply it with 5 by 18. 5 by 18. It means if there is given that 18 kilometer and we have to change it into meter per second, then we will simply multiply it with 5 by 18, and the answer will be 5 meter per second. Okay. Vice versa, if we have to change meter per second into kilometer per hour, then we will do reciprocal of the fraction, that is 18 by 5 and kilometer per hour. Okay. In the second case, if we want to change kilometer per hour into meter per minute, then again we have to do the same thing, that kilometer into meter, that is 1 kilometer is equals to 1000 meter, and 1 hour is equals to 60 minutes. After terminating both the terms, we will get 50 by 3. So if we have to change kilometer per hour into meter per second, then we have to simply multiply it by 50 by 3, and vice versa, if we have to change meter per minute into kilometer per hour, then we have to multiply it with the reciprocal of the fraction, that is 3 by 50. So this was some basic concept about speed, time and distance. Now we will move towards boat and stream and get ourselves familiar with some terminology that is frequently used in boat and stream. So the first term is still water. Second is downstream. Third is upstream. Still water, by the name we can understand that we are talking about the still water, that is the water does not have the current. The water does not have the current. If we are talking about the downstream, then we can conclude that water is flowing, let's say in this direction, and a man sitting on the boat also going in the same direction. The man sitting in the boat is also going in the same direction, and it is the example of downstream. When the direction of current and the boat is same. If we talk about the upstream, then water is moving downward, but the man on the boat going upward. So when the direction of the stream and the boat is different, then it is said to be upstream. Okay. So it was all about the 3 different terminologies of boat and stream. Now we will move towards the questions. Okay, one more thing. In this case, we take the speed of boat as x and speed of current as y. Speed of boat, that is boat is moving with x km/h and the speed of current is y km/h. Similarly, boat is moving with x km/h and the stream is going with y km/h. Okay, so speed of boat is x and the speed of current is y. Now we will discuss our first question, that is very basic question. If the speed of the boat in still water is 4 km/h, speed of the boat, and we have just saw the speed, we denote a speed of the boat with x. It means x is equals to 4 km/h and speed of the stream, that is y, is equals to 2 km/h. Then find the speed of the boat in downstream. Okay, speed of the boat in downstream, and we have just saw then in downstream both the current both the speed of both the current and the boat are moving in the same direction. Both the current and the boat is moving in the same direction, so we will add the speed of boat and speed of current. We will add the speed of boat and speed of current, that is x plus y, and that is 4 plus 2. It is equals to 6 km/h. So we can say that the speed of boat downstream is 6 km/h. Similarly, so in case of downstream, we add the speed of stream and speed of boat. Point to be remembered. Okay. If the speed of boat in still water is 6 km/h, speed of boat, that is x, is equals to 6 km/h, and the speed of stream is 12 km/h, that is y is equals to 12 km/h. Then the speed of the boat in upstream, as we have saw here, that in upstream, in case of upstream, the speed of stream and speed of boat, direction of stream and direction of boat is in different direction. So we will simply subtract the given values, that is x minus y. There is an error in this question here. X will be 12 and y will be 6, and 12 minus 6 is equals to 6 km/h. So we can say that in case of upstream, we subtract the speed of boat and the speed of stream because they are in the different direction. Point to be remembered. If the speed of the boat in downstream is 24 km/h and the speed of boat in upstream is 12 km/h, then find the speed of the boat. Here we have given the downstream, the speed of downstream, that is x plus y, is equals to 24, and the speed of upstream, that is x minus y, that is 12 km, and we have to find the speed of the boat, that is x. Whenever we have given this kind of situation or question, we just add both the speed and divide it by 2. 24 plus 12 by 2, that is 18. Reason behind it is x plus or plus, here 2x plus minus or plus minus or plus, y will be cancelled, 2x is equals to 36 and x is equals to 18. So whenever we have to find the speed of the boat, then we will simply add the speed of downstream and the speed of upstream and divide it by 2. In the next question, if the speed of the boat upstream is 102, that is x minus y is equals to 102, and downstream, that is x plus y is equals to 96, and we have to find the speed of the stream. We have to find the speed of the stream, that is y. Then in this case we will subtract and divide it by 2. X and x will be cancelled. 2y is equals to 198, I think. 6 to 8, 198. Okay, then y is equals to 198 by 2, 99 kilometer per hour. The speed of the stream is 99 kilometer per hour. Okay. In the next question, a man can swim at the rate of 4 kilometer per hour in still water. Okay, man can, here it is given a man. A man can swim at the rate of 4 kilometer per hour. So if we replace man with a boat, then there will be no change in the question. That here we can take speed of man is equals to x, that is 4 kilometer per hour. The speed of the man in the still water is 4 kilometer per hour, and the speed of the water is 2 kilometer per hour, that is 2 kilometer per hour. Speed of the water or speed of the stream. Then the time taken by him to swim 10 kilometer upstream. 10 kilometer upstream, that is x minus y. And here we have to find the time, and we have already discussed that time is equals to distance upon speed. Here we have given 10 kilometer hour distance, and we have to find the speed, that is x minus y, because we are going upstream. This x minus y is equals to 4 minus 2, that is 2. So our answer would be 5 kilometer per hour. 5 kilometer per hour. We have just changed the name, we have just changed the term. We have replaced man with boat. The speed of the boat in still water is 4 km per hour, and the speed of the water, that is speed of the stream, is 2 km per hour. And we have to find the time taken by him to go 10 km upstream, that is x minus y, that is 4 minus 2. Okay, moving towards the next question. A man can swim at the rate of 20 km per hour in still water. If the speed of the water is 5 km per hour, then time taken by him to swim 100 km downstream. Same question. Man can be replaced by boat. So x is equals to 20 and y is equals to 5, and we have to find the time, that is time is equals to distance upon speed, that is 100 upon 20 plus 5, 25. 25 into 4, that is 100. 4 hours. 4 hour is the correct option. Moving towards the next question. The speed of a boat along the stream is 12 km per hour, and against the stream is 8 km per hour. Along the stream, that is x plus y, is 12 km per hour, and against the stream, that is x minus y, 8 km per hour. The time taken by boat to sail 24 km in still water. 24 km in still water. Again we have to find the time, that is distance upon the speed. And distance is 24. And we have to find this time taken by boat to sail 24 km in still water. We don't have to find the downstream time or upstream time. We have to find the time of still water. So again we have to find the x, value of x, y, and y got cancelled. 2x is equals to 12 and 8, 20. 12 and 820, then x is equals to 10 kilometer per hour. Then this would be the speed of boat in still water. Speed of boat in still water. Then we will put it in the formula, that is 24 by 10, that is 2.4 hours. 2.4 hours is our correct answer. In the earlier question, we have to find the speed, we have to find the time taken by the boat to go downstream, and here we have to find the time taken by the boat to sail in still water. That is why we have to find the x here, not the x plus y or x minus y. Moving towards the next question. There is a slight change in the language, but our concept would remain the same. A boy can swim in still water, at a speed of 10 km per hour. If the speed of current would have been 5 km per hour, then the boy could swim 60 km. Here we don't have given the direction of the boat, that is, the boy is going either upstream or downstream, so we have to go with the hit and trial method. That 60 km, a boy can so swim in still water, that x, we have given x is equals to 10 km per hour, and the speed of the current would have been 5 km per hour, that is y is equals to 5 km per hour. Then the boy could swim 60 km, that is distance. The time is equals to distance upon speed, that is 60 upon speed. First we will apply 10 plus 5, that is 15 upon 4, 15 into 4, the 4 km downstream. We got the answer in the first hit, that is 4 km downstream. 4 hour in downstream. Sorry. If we had just subtracted x minus y, we would have get 5 km per hour. After putting it in the formula, 15 km upstream, 15 hours in upstream, 15 hours in upstream. That is not given in our option, so the correct option is 4 hours in downstream. Okay, this is our last question of this chapter, that a man can swim 3 km per hour in still water. Again, the speed of x is equals to 3 km per hour. If the velocity of the stream, velocity matlab speed of the stream is 2 km per hour, the time taken by him to swim to a place 10 km and back. So in the first go, swimmer is going 10 km away and again coming to the same point after covering the 10 km. In this case, we have to understand that the direction is changing, but the direction of water flow is not changing. So in the first case, the boy will go downstream, that is with the current, and the second go, he will come against the stream. So we have to find the time of two different cases. First, the time is equals to distance upon speed. One second. Distance upon speed. So given distance is 10 km per hour. And the speed would be 3 plus 2, that is 5. So in the first case, when the boy is going with the stream, his speed would be 5 km per hour. And the second case, when the boy is coming against the stream, that is 3 minus 2 x minus y. X minus y, we have already discussed that the speed of a stream, if we are moving against the stream, then we just subtract the speed of boat and speed of a stream. That is 3 minus 2, that is 1. And the answer would be 10 km per hour. Oh, sorry, per hour, 10 km per hour, not only hours. Only hour. So total time would be 10 plus 5, 15 hours. Add one more option here, that is 15 hours. So this is one of the approach. If we want to approach this question in the different manner, then we will take a formula. With the help of this formula, that is total time would be 2 into d into x upon x square minus y square. Here d is equals to total distance covered by the boy, x speed of stream, speed of man or boy or boat, y speed of stream, we will put the values in the formula, that is 2 into 10, and the speed of stream is, the speed of boy is 3 into 3 upon 3 square minus y is 2 square. We have already studied that a square minus b square is equals to a plus b, a minus b. We will apply this here. 2 into 10 into 3, 3 plus 2, that is 5, into 3 minus 2, that is 1. The boy will cover the whole distance in 12 hours itself. And first, against the stream, he is going against the stream, that is 5. Oh, 5 into 2 hours, that is 12 hours. So our option was absolutely correct. We don't need to add one more option here. 5 into 2, 10, 2 hours in case of downstream, and 10 hours in case of upstream. 10 plus 2, 12 hours is the total time. And with the help of formula 2dx upon x square minus y square, we will simply get the answer in less time, that is 12 hours. I hope you like the video. Have a good day. Bye.